or 1 meters per square second during 4-second period. Okay guys, this is our second lesson in science. We discussed about chemical basis of life by 2 videos as part 1 and part 2. So this is lesson number 2, part 1, motion in a straight line. So let's see. Okay, our first subtopic is distance and displacement. This blue color path is distance and the red color path is displacement. Distance is longer than displacement. I'll explain the terms distance and displacement in next slides. Path from A to B. There are 4 paths and path P is 320 meters, the blue color one, and the path Q is 200 meters, the yellow color one, and path S is 160 meters, black colored one, and path R is 240 meters, the green color one. When you go from A to B, there are some long paths as well as short paths. The shortest path from A to B can be named as displacement. So, the shortest path from A to B, path P is 320 meters and path Q is 200 meters, path S is 160 meters, path R is 240 meters. The shortest path from A to B is path S, 160 meters. So path S is the displacement. The other paths are distance. The blue colored one, yellow colored one and green colored one are distance. A physical quantity which can be described only by its magnitude is called a scalar quantity. In other words, a physical quantity which has only a magnitude, not a specific direction, is known as a scalar quantity. Examples: speed, mass, distance and time. Examples for scalar quantities are speed, mass, distance and time. A physical quantity which can be described by its magnitude and direction is called a vector quantity. In other words, a physical quantity which have a magnitude as well as a direction is called a vector quantity. Examples: displacement, velocity, acceleration and weight. Examples for vector quantities: displacement, velocity, acceleration and weight. Okay, let's see some examples to display distance and displacement. From A to B, okay? So from A to C first 200 meters and C to D 400 meters and last D to B 100 meters. So 200 meters plus 400 meters plus 100 meters equals 700 meters. The distance from A to B is 700 meters and the displacement is 500 meters. See, the shortest path is 500 meters and the other path is the distance, 700 meters distance, 500 meters displacement. Okay, this is another example from A to C. So the distance is from A to C 60 meters plus 40 meters. 60 meters plus 40 meters equal 100 meters. And the displacement is 60 meters plus 40 meters because this is the shortest path from A to C. So the both distance and displacement are equal, 100 meters, 100 meters. This is our final example from A to B. And this object has moved from A to B and again come to C. See? From A to B and again to C. A to B again to C. Distance equal 60 meters from A to C and C to B 40 meters. and B to C 40 meters. A to B and again to C 60 meters, 40 meters and again to C means we need to add another 40 meters to find the distance. 60 meters plus 40 meters plus 40 meters equal 140 meters. So let's find displacement from A to C, A to B and again to C. That means the shortest path is A to C. I mean the shortest path from A to C is this, and this line is 60 meters. See, A to C is 60 meters. Displacement equals 60 meters. This long path is distance and this shortest path or short path is displacement. Okay, let's talk about our second subtopic, speed. The distance traveled in a unit time is known as speed. The distance traveled in a unit time is known as speed. Some examples for speed are speed of a falling object, speed of vehicles running on track, speed of runners. And also the quantity speed is a scalar quantity, which means has a magnitude but not a specific direction. The physical quantity speed is a scalar quantity. The speedometer of the car indicates the magnitude only. In other words, only the speed is indicated by speedometers. So, we can conclude that speed is a scalar quantity. The unit of measuring speed is meters per second. The unit of measuring speed is meters per second, ms minus 1. The equation to find speed is speed equal distance divided by time. The equation to find speed is speed equal distance divided by time. Okay guys, let's solve some problems related to speed. To solve problems, we need to memorize this equation, speed equal distance divided by time. And the unit of measuring speed is ms minus 1 or meters per second. Okay guys, let's solve some problems related to speed. Okay, our first problem is there's a table and there are times and distances. In 0 seconds, distance traveled is 0 meters. In 1 second, 3 meters. 2 seconds, 6 meters. 3 seconds, 9 meters. 4 seconds, 12 meters. 5 seconds, 15 meters. And 6 seconds, 18 meters. You can see that the difference of distance traveled in each second is 3. See 15, 16, 15, 16, 17, 18. 3. 12, 12, 12, 13, 14, 15. 10, 11, 12. See 3 meter gap. There's a 3 meter gap. So we can name these kind of speeds as uniform speeds. It's traveled uniformly, 1 second to 3, 2 second to 6, 3 second to 9, 4 second to 12, 5 second to 15, 60 seconds to 18 meters. So let's find speed. Distance is we can get any distance and any time, but it must be in the same rectangle like this. If we get 15 as the distance and time as 5, the answer is 3 ms minus 1. Distance, the unit of distance is meters and the unit of time is seconds. By dividing them, we can get the answer as 3 ms minus 1 or 3 meters per second. And also these kind of speeds can be named as uniform speeds. Okay, let's discuss our second problem. So here we can't take the gap as 3 or 4 or 5. See, the difference of 3 and 5 is 2, and the difference of 5 and 9, 4. The difference of 9 and 12, 3. 12 and 16, 4, and 16, 18, 2. So this is not uniform, right? In 1 second 3 meters, 2 second 5 meters, 3 seconds 9 meters, 4 second 12 meters. It's not uniform. The gap is different. So these kind of speeds can be named as mean speeds. Mean speeds. Okay, let's calculate the speed. We need to get the speed, distance as the total distance and the total time. So as the distance we can get the 18, and as time we can get 6. 18 divided by 6 equal 18 meters divided by 6 second equal 3 ms minus 1. So the answer is 3 ms minus 1 or 3 meters per second. And these kinds of speeds can be named as mean speeds. Okay, let's talk about our third subtopic, velocity. The displacement traveled in a unit time is known as velocity. What is the definition of speed? Distance traveled in unit time. And the definition of velocity is displacement traveled in unit time. The unit used to measure the velocity is meters per second. Both units are equal because we measure speed also by this unit, meters per second or ms minus 1. And also the quantity velocity is a vector quantity, which means has a magnitude as well as a specific direction. Velocity also can be moved as uniformly or not uniformly like speed. This is speed, not displacement. I missed it. Velocity can be measured by dividing its displacement by time. The equation to find velocity is velocity equal displacement divided by time. Velocity also can be moved as uniformly or not uniformly like speed. Velocity can be measured by dividing its displacement time by time. This is the equation. Velocity equal displacement by time. Okay, let's talk about or find or solve velocity related problems. Okay, our first problem is there's a table given time and displacement. For 0 seconds 0 meters, 1 second 2 meters, 2 4, 3 6, 4 8, 5 10, 6 12, 7 14, 8 16, 9 18, 10 20. So you can see that this is uniform, right? 2 meter gap. There's a 2 meter gap in every displacement. Every two displacement. 18 to 18 to 22. 16 to 18 2, 14 to 16 2, right, 2 to 4 2, 4 to 6 2, 8 to 10 2, 10 to 12 2. So this is uniform, right? These kind of velocities can be named as uniform velocity. And the formula to find velocity is displacement divided by time. So let's solve it. We can get any displacement and time as a rectangle like this. Any thing, any numbers by but like this. Okay, let's get this displacement 2 meters and time is 1 second. So the answer is 2 meters per second or 2 ms minus 1. Okay, let's get this displacement is 20 meters and the time is 10 seconds and the velocity is 2 ms minus 1. The same answer. So these kind of velocities can be named as uniform velocities. So in this table, the time and displacement given. So 0 seconds to 0 meters. 1 seconds 2 meters. 2 seconds 3 meters. And 3 seconds to 6. 4 to 9. 5 to 11. 6 to 13 and 7 to 14. So this is not uniform, right? The gap is different. 2, 3 and 1. Here the gap is 3. 6 to 9, 3. 9 to 11, 2. 11 to 13, 2. 13 to 14, 1. So the gap is different. So these kind of velocities can be named as mean velocity. Like speed. Mean speed and mean velocity. So in this case also we need to get the total distance like this and the total time as this. Okay, so the total distance equal 14 meters and total time is 7 seconds. So we can get the answer as 2 meters per second or 2 ms minus 1. And these kind of velocities can be named as mean velocity. Okay, our final subtopic is acceleration. The change of velocity per unit time is acceleration. Change of velocity per unit time. This physical quantity acceleration is a vector quantity. Acceleration physical quantity is a vector quantity. It means acceleration quantity has a magnitude as well as a specific direction. The unit used to measure acceleration is meters per square second. In other words, ms minus 2. The formula to find acceleration is change of velocity divided by time. And change of velocity means final velocity minus initial velocity. Formula to find acceleration is change of velocity divided by time, and change of velocity is final velocity minus initial velocity. If the velocity is increasing, there is acceleration. If the velocity increasing, acceleration. If the velocity decreasing, deceleration. If the velocity is decreasing, there is a deceleration. If the velocity is decreasing, there is a deceleration. And if the velocity is increasing, there is an acceleration. Okay guys, so let's talk about differences of acceleration and deceleration. Acceleration. Acceleration occurs when increase in speed. Deceleration. Deceleration occurs when decrease in speed. Acceleration increase in speed. Deceleration decrease in speed. We can get a positive value after solving acceleration equations, and we can get a negative value after solving deceleration equations. But the same equation for both. Okay, acceleration equation to find acceleration and also the deceleration. Acceleration happens when there is a resultant force on an object in any direction. Resultant force on an object in any direction. Deceleration happens when a resultant force acts on an object in the direction opposite to the direction in which it is moving. Okay, let's solve acceleration equations. Okay, the equation to find acceleration is change of velocity divided by time. This is acceleration. So the equation to find acceleration is change of velocity divided by time. Change of velocity means Let's solve this. We can see that in the table the time and velocity is given. So 0 to 0, 1 to 2. It's not compulsory in this case because there are no uniform or mean acceleration. So here only thing we need to do is find final velocity and initial velocity. So let's solve this. Final velocity is 12 meters per second and the initial velocity is 0. See, the initial and the final. Initial means first velocity. Final velocity 12 ms minus 1 minus 0 ms minus 1. Time is 6 seconds. Okay, the answer here is 12 ms minus 1, and if we divide it by 6, we can get the answer as 2 ms minus 2, because this unit of representing acceleration is meters per square second or ms minus 2. Okay guys, let's solve another one. Okay, in this case, this is acceleration again. I am sorry for that. Change of velocity divided by time, the equation to find acceleration. And change of velocity is final velocity minus initial velocity. So, in this case, final velocity is 0. See, final velocity. And this is initial velocity. And the time is 4 seconds. So, let's solve this. 0 ms minus 1 minus 12 ms minus 1, because this is final velocity and this is initial velocity, and divide by 4 seconds, and here minus 12 ms minus 1 4 seconds. We can get the answer as a minus number, minus 3m minus 2 or minus 3m square second. We learned that if there's a minus answer, it is a deceleration. So, when we are representing deceleration, we need to cut that minus and just write it. Deceleration equals the previous one is 3 ms minus 2. So the deceleration is 3 ms minus 2. If we get the answer as acceleration, this is correct, and if we get the answer as deceleration, this is correct. Okay, if there are any doubts, comment below. Okay, comment down in my comment section. Okay, let's get into another question. If the velocity of an object, this is activity 2.2 in your textbook. If the velocity of an object increases uniformly from 0 ms minus 1 to 12 ms minus 1 during 6 seconds, find the acceleration of the object. So we need to calculate the speed here. This is acceleration, I am sorry. So the initial velocity is 0. The object increase uniformly from means starting from means initial velocity from 2 to lm minus 1. So this is final velocity. Let's solve this, and the time duration is 6 seconds. Then we have all the requirements, and let's solve this. Final velocity 12 ms minus 1 minus 0 ms minus 1 and divide by 6 seconds. 12 ms minus 1 divided by 6 seconds equal 2 ms minus seconds, or 2 ms minus 2. Okay, let's solve the other 3 questions also. If the velocity of an object decrease means there's a deceleration uniformly from 16 ms minus 1 to 4 ms minus 1. So 16 ms minus 1 is the initial velocity, and the final velocity is 4 ms minus 1 during 4 seconds. So we have all the requirements, and let's solve. Find the deceleration. This is speed, acceleration, sorry. Okay, final velocity minus initial velocity. So final velocity is 4 ms minus 1 and subtracted by 16 ms minus 1. Time is 4 seconds. So the answer in here is minus 12 ms minus 1, because 4 subtracted by minus 16 ms minus 1, 4 seconds. So there's a minus number. We learned that if there's a minus number, it's a deceleration. Okay, so the answer is 3 ms minus 2, or 3 meters per square second. And the final answer is, they are saying that deceleration, find the deceleration. So the final answer is acceleration is 3 ms minus squared minus 3m minus squared acceleration, and the deceleration is 3 ms minus squared. This is the final answer. So easy. Let's solve some other questions also. Okay, starting from rest, if an object traveled with an acceleration of 0.5, so they are given acceleration as 0.5 ms minus squared or meters per square second for 10 seconds. So the time is 10 seconds and this is acceleration. Acceleration is 0.5. And we find the velocity of the object at the end of 10-second period. Object has started from rest. Rest means 0. That means initial velocity. We need to find the final velocity. So we can get the acceleration as 0.5 ms minus 2 here, and change of velocity means final velocity minus initial velocity, no? So we need to find final velocity. We can represent final velocity as x because we don't know about that. Initial velocity is 0. Time is 10 seconds. So first we need to multiply both sides by 10 seconds. We can get the answer as 50 ms minus 1 because second to second cancel out and 1 second remain. In this, we can get the answer as x because if we subtract x by 0, there's no value, no? 0 is valueless. So we can get the answer as final velocity is 50 ms minus 1. Final velocity 50 ms minus 1. So the final answer is 50 ms minus 1. Let's solve another question about acceleration. The velocity of an object moving on a straight line was 2 ms minus 1 at a certain instant. Its velocity changed to 6 ms minus 1 after accelerating for 4 seconds. Find the acceleration during the 4-second period. So we need to find the answer acceleration of 4-second period. The velocity of an object moving on a straight line was 2 ms minus 1 at a certain instant. That means the initial velocity is 2 ms minus 1. Initial velocity. And the final velocity is 6 ms minus 1. The time is 4 seconds. So we have all the requirements and let's solve. So easy. Change of velocity is final velocity minus initial velocity. So final velocity is 6 ms minus 1. Initial velocity is 2 ms minus 1. And the time is 4 seconds. 6 ms minus 1 minus 2 ms minus 1. 4 ms minus 1. 4 seconds. The answer is 1 ms minus 2 or 1 meters per square second during 4-second period. The acceleration during 4-second period is 1 ms minus 2. Okay guys, we finally finished the questions of these physical quantities, and I will conduct other part of this lesson in my part 2 video. So if you need to something clarify on these questions, leave a comment on comment section. Initial velocity. So let's go to our video. Okay guys, this is our end of part 1 video. So if you like this video, put a like, and if you need to something clarify, leave a comment, and don't forget to subscribe. So bye bye.
Hey guys, welcome to our YouTube channel FebTV Sri Lanka. Actually this is our first video. We have already planned to do science videos. That means we will start it from the first lesson of grade 10. As the welcome video, I am going to introduce our future plan. So here what we are doing here is we do free MCQs using Telegram app. You can pause or you can rewind that video to the starting point and you can watch it later or now. So you can see how we do it. If you now watching the left hand corner, when we touch the correct answer like that way, in that way we can have the correct answer. And we have planned to do timing MCQs also. So here it indicates a specific time. Within that time we have to choose the correct answer. If not, if the time passes, question will automatically remove. And if any incorrect answer is given, it indicates in red color. So all what you have to do is go to Play Store and download Telegram app, and I will mention the link in the description, and you can tap on that link and come to our groups. So let's get started our video.